Even without a formal definition of limit, we can calculate limits and find the function value compared to a function value, which is something we already know. So let's look at this graph we have on the screen, and let's compare the limit as x approaches 1 of f of x with f of 1, for example. So looking at the graph right here, x equals to 1 is here, and this point here shows me that f of 1 equals to 2. So this is easy. This is something you've done before. Now, what is the limit of f of x as x approaches 1? So this definition on the top here is telling me, and this is the notation we're going to use. This is not formal. This is an idea. We're going to say that the limit equals L if we can make f of x as close to L as we want, as long as we make x close enough to a. Here our a is 1. So what happens to f as I get closer and closer to 1, right? Before I actually reach 1. So let's say, what would be f of 1.1? I don't quite know, but it would be very close to 2. The closer I get to 1, the closer I get to 2. So that would mean that the limit of f of x as x approaches 1 equals to 2 as well. Okay, so that's our first step, our first item there. The second item, and I'll change colors, is that x equals to 2. So we're right here now. So what is f of 2? We go all the way up. This is the filled in circle. F of 2 equals to 5. You've done that before. Now, what is the limit of f of x as x approaches 2? So what would happen if I plugged in x equals 2.1? What would f of 2.1 be, right? That's the question. Or not necessarily 2.1, it could be also 1.9 or 1.99, something very, very close to 2. Graphically, I can see that if I follow this graph, before I actually reach 2, I'm getting closer and closer to 2, I get close to 3 and not to 5. So the limit is 3. Okay? So the limit actually does not care about the function value, and these two are different. This is a situation we're going to describe later. This is a continuity situation. This function is not continuous there at x equals 2. Limits exist to detect this type of situation. Okay, now let's go to our last example at x equals 3. So we're at 3 now. We have a hole in there again. So what is f of 3? This time there's no filled in circle. So I'll say is undefined, or does not exist. You can say that too. And what is the limit as x approaches 3 of f of x? So same thing, follow the graph closer and closer to 3. Doesn't matter what happens when you reach 3. What happens when you approach 3 is what matters from either side. And you're getting closer and closer to 4 in the y-axis. So the limit of f of x as x approaches 3 equals to 4. So again, these two can be completely separate, both the limit and the function value at the point. One can exist and the other not exist, and they can be different.